Hi friends, I am Yashwardhan and welcome back to my YouTube channel. Friends, if you remember a few weeks back, I have done a video on how you can design a monopole antenna using HFSS software. On that video, I got a comment to design a CPWFN monopole antenna for broadband purposes. So in this video, I am going to do that. And to do this, I am going to the figure which I selected from the net is this figure. Now you may ask me, and these are its dimensions, and all these dimensions will be in millimeter. And in this figure, even though they took the axis as this as y-axis and this as x-axis, but when I am doing this in HFSS, I am going to take it in reverse order. That is, okay, let me go this. That is, instead of this I am taking as my x-axis, and this I am going to take it as my y-axis, friends. So don't confuse when I am doing this. Okay, next. So with this out of our way, let us begin, friends. Now with this initial talk out of our way, let us move on to the main designing this antenna in HFSS software. To do this, first click on the HFSS icon that is present on your desktop screen, or you type the HFSS software in the screen and open it. Then close this, sorry. Now go to project 1, rename your project and save it. Click on save as and save it in the folder where you want to store it, right? And for example, let me give it a CPWF monopole. Okay, and click save. Now, so as the first step, click on HFSS design icon to insert an HFSS design. Now, go to HFSS. In HFSS, go to the solution type, select it as model network analysis, or else you can select it as terminal network analysis and click OK. Then go to modular, go to units and select your units as millimeter and click OK. Now friends, now with all these basic things out of our way, let us move on to the designing this antenna. So first let us design this monopole antenna, which is this tall rectangle I am considering. Your monopole antenna need not be a tall rectangular, straight rectangular conductor. It can be in circular shape, or else it can be in cylindrical shape also. It can be in rectangular, it can be in hexagon shape, or it can have some arbitrary shape also. There is no issue with that. Now, to begin with this, let us create the draw rectangle tool and draw one small rectangle like this. Now, rename your rectangle as monopole. Select some color as default color and click OK. Now, coming on to its dimensions will be, I have already done this, practiced this, I already tried to do this, so I am just keeping the dimensions here, and this dimension will be 22 and this x dimensions should be 2 millimeter, and I will say how I got this also, friends. Now if you see this is the figure which this is the diagram which I am going to realize in HFSS software, right? So if you observe, this length is left, which is nothing but 22 millimeter, and this is along y-axis according to this figure, but in our HFSA this is along x-axis, and this width is WF, which is nothing but 2 millimeter, and yeah, so that's and it is along y-axis. Okay, so that's what I fed here and click OK. Now just click on this icon to see it clearly. Now let us move on to the next step, which is nothing but designing a planes. This ground plane here and this is other ground plane which is having a stub. This stub is nothing but to increase the HFSS property. To increase the antenna parameters, we use this stub, and also there's a slit here. This slit is used if you want to add some additional source to this. But in my design, I'm not going to add any additional source, but I will keep this slit in case if any one of the person who are seeing this video want to add any external source. Now, so let us draw the second thing, which is nothing but drawing this rectangle. You may ask me, Yashwardhan, I can clearly say that my x dimension is h, which is nothing but 8 millimeter. That's okay. But what about my y dimension? You may ask here. It is easy to calculate. You see this. This is WF, which is nothing but 2 millimeter, and this gap is same, which is having zero point 0.2. So from here to here we have a distance of, say that it is having 2.4 distance. So now the total width is 24. If we remove 2.4 from it, we have 21.6. Out of 21.6, this is occupying equal, and this is also equal. So if we divide 21.6, we get 10.8. That's what we need to do. Then go to draw a rectangle and draw one rectangle like this here. Now rename your rectangle as plane number 1. Select the color like some green color and click OK. Click OK. Now its dimensions will be nothing but, its dimensions will be 3, position will be 3 comma minus 10 comma 0. It will be along z axis only. Its x size will be 8, which is nothing but h, and the y size will be 10.8 millimeter, and click OK. Similarly, if you observe, this is the figure, this part of figure is over, but now we need to do this side. But if you see this is clearly a small simple rectangle, but here the structure is complex. So to draw this, design this structure, I am going to split it into parts. That is I am going to draw this whole thing as one rectangle. Sorry friends, I am using my mouse. And this one as one rectangle, and this whole part as a rectangle. Okay, no, sorry, eraser. Okay, yeah, again go to this. Okay, and this part as one rectangle, and this whole thing as a rectangle. Okay, okay. Now to do this, we know this distance d is 3.25 and this is 10.2, 10.8 millimeter. So let us draw that only first. So to do this, just draw one rectangle here. Sorry, you need to make sure. Okay, you need to make sure that you have enough space to move your mouse. Now, yeah, name this as your plane number 2. Plane number 2. Let us give it some green color only. Click OK. Click OK. Now coming on to its coordinates, it will become 7.75 comma 3.2 and comma 0 degrees 0 millimeter, and it is having an x size of 3.25 millimeter, and it is having a y size of 10.8 millimeter, and click OK. Now first part is over. Now let us draw the second part, which is this small rectangular part here, which is having a width of W1 and the length is nothing but, out of 10.8 we need to remove L1, which is 5.5. If we remove, we get 5.3. That's what we are going to design next. So just draw one rectangle box, small rectangle here, and it should touch it. Now rename this rectangle as nothing but plane number 2 underscore 1, which is nothing but, as it's a part, I am naming it as anything. You can name it as anything of your choice. Click OK. Now go to here, go to its parameters. Its parameter will be nothing but 7.75 comma 8.7 comma 0. Its x size is nothing but minus 0.6 and its y size is nothing but 5.3 millimeter, and click OK. Now we have got the thing. Now similarly, let us draw the second another plane also. That is, we need one more rectangle, right? For this is the another rectangle part we need. So just draw that. Now let me draw that also for you. Go to here, Now rename this as your path number 2. So that means lane 2 underscore second path, and it is having some green color suppose, and click OK. Now go to here. Now its dimensions will be nothing but 3 comma 3.2 comma 0. It is having an X size of 4.15 millimeter, and it is having a Y size of 10.8 millimeter, and click OK. And these distances are easy to calculate. You need to make sure, as you know all this distance, you can find the other distance, and accordingly you can draw. Now we also need to design the stub here. So to do that, plane number 2 underscore 2, or you can name this as your stub. Let it give it the same green color, suppose. Click OK. Now the stub dimensions will be nothing but, it is nothing but 3 comma, it is having that same 3 comma 3 comma 0.2. Now it is having an X size of minus 7.5, and it is having a Y size of 1, and Z direction only it should be, and click OK. Now the stub is also created. But if you observe our main figure, which we are taking as the basis to design a design, you observe this whole thing is acting as a part. It is not like this, that is, it is not separated. So to do this, select plane number 1, select plane number 2. Okay, let me just minimize the screen. So plane number 2, plane 2.1, 2.2, and your stub. Then go to tools. Now we need to unite this. So to this, go to boolean, go to modular. In that, go to boolean, go to unite, and we have united. See, this whole thing is now acting as a part. You can click on this and you can see the other thing. Now a basic step of an antenna is over. Now we need to design the substrate, which is having length L, which is 12.5, width of 24, and it is a box, so it is having a height of 1. So to do that, just minimize the screen a bit. Okay, now go to draw a box and draw one small box like this simply, and draw one small box like this. Now go to box, rename your box as nothing but a substrate. Okay, substrate, and select the material of your substrate as FR4 epoxy, which is having a relative permittivity of 4.4 and a relative permeability of 1. Click OK. Let us give this color like some peach color. Click OK and click OK. Now coming on to its dimensions, its dimensions will be, just give me a minute. Its dimensions will be 11 comma minus 10 comma 0. Its X size will be minus 25. Its Y size will be 24 as it is, and our Z size should be minus 1. And click OK. You may ask me, Yashwardhan, why is this distance? Because according to a figure, we have took some distance extra here. So that should also be reflected in this antenna. Now your basic designing is over. Now let us assign the different excitation. To do this, just go to monopole. You need not assign anything. Go to plane number 1, go to assign boundary and select perfect electric field. Click OK. Leave everything in default and click OK. Go to this, select the plane number 2 and click OK. Assign boundary and click perfect electric field and click OK. That's it. Now if you want me to say, Yashwardhan, how can I verify whether the excitation is assigned or not? To this, go to boundary, select your perfect electric field 1, it is assigned. Perfect electric field 2, it is assigned. If you want, you can even assign to this to this monopole also. I am not assigning at present, but I will show you at the last the difference between this by exciting this and without exciting this also, so don't worry. Now next we need to assign the excitation to this, or we need to assign the source. So to do this, go to rectangle and draw one small rectangle and change your axis first of all to YZ axis, and yeah, okay, sorry, yeah, go to rectangle, draw rectangle tool, go to draw a rectangle and draw one small rectangle like this. Okay, yeah, okay, select the rectangle. This is a rectangle. Then let me select yellow color and let me name this as my source. Click OK. Now coming on to its dimensions, this source can be of two types. You can either assign this source as 11, 0.5, 0, and it is having your y size as y as 3 and your z size as -1, and it is having x, and click OK. Now this is one way of exciting this. If you observe, if you see this here also, in this design, this my source is touching display as well as display and a monopole antenna as well. You can, this is one way. Or else you can design a normal rectangle also, and you can do this. Now if you may ask, Yashwardhan, should we assign a ground plane or not? It's up to your wish. If you want, you can assign the ground plane, or else you can take these both planes as your ground. There's no need of assigning separate ground plane yet, because this and this should act as a ground plane only. Now so that's why we have connected this port. Now let us assign the excitation to this source. So select the source, go to assign excitation, lump the port, leave everything in default, and go to integration and select a new line. Now just maximize this for your convenience, and this is the middle point. From here to this point there should be an excitation. Click next, leave everything in default and click finish. Now our excitation is over. To select this, go to HFSS design, go to excitation and select this. Our excitation is also assigned. Now next we need to assign the outer radiation box or the far field region where you want to calculate the our antenna parameters and our radiation parameter. To do this, select your axis to xy, and go to draw box and draw one small draw an arbitrary box like this first of all. Good. Now rename your box as nothing but radiation. If you want, you can change the material as vacuum or air. It's up to your wish. Let me select this blue color as color, and its transparency should be minus more than 9 is recommended. I am taking at 9.7. Click OK and click OK. This is because, see, now I can see this direction. Now I am also going to assign the parameters to this. Now you may ask me, Yashwardhan, what will be its parameters? Its parameters will be nothing but -18, -12, 5. Its x size should be 33, y size should be 28, and the z size should be -11. Click OK. These are the dimensions I took, so that now if you observe, okay, sorry, yeah. Now if you observe, see, our whole design is at the middle of this antenna. To do this, I have taken this parameter, but according to your design, you can change them also. Now, by this, now you need to just assign an excitation to this also. To go to radiation, go to assign a boundary, in that select radiation and click everything, leave everything in default and click OK. Now again go to boundary and select radiation, and you see a radiation. Now by doing this steps, you have completed designing your antenna. Now let us move on to analyzing an antenna parameter. To do this, go to analysis, Right click on it and click add the solution setup. Let us say as we are designing for broadband, let me say its solution frequency is 5 GHz, maximum number of passes are 25, and click OK. Now click on analyze on to see when if you see all those things, if everything is okay, then click on analyze on to analyze your design. This analysis may take time. Friends, now if you have any doubts or if you are doing this parallel with me, you can stop the video at the point where you are, complete the steps up to this and go to here. See, if you go to here, you see normal completion is done. That's it. Now you have completed the things. Now let us analyze the different results. Go to results. In this results, go to create model solution data report, rectangular report. Leave everything in this only, like S parameter, S11, decibels. Click new report. Okay. Friends, you may now ask, Yashwardhan, you have done all the set, but why I am not getting this? There is a simple reason there is. It is done. If you observe carefully, when I am assigned the solution setup, I didn't assign any frequency sweep to it. So now let us rectify this. So select your solution setup and click add a frequency sweep. Select your sweep type as fast. Select this in linear step only, as we are calculating our operating frequency is 5 GHz. Let us say it starts at 1 GHz, stopping at 10 GHz with a step size of 0.1 only. There is no doubt in it, and click OK. Now click analyze on, and now again click on analysis to analyze your design. Okay, that, like some friends asked me even that doubt, that they were doing everything as I said, but they are not getting the graph. This may is one of the this may be one of the error that you may be doing. That is, you are assigning the solution here, but you are forgot to assign the frequency sweep to it. Okay. Now again, if you see your result is not plotted, just delete this. Sorry. Go to results. In this, go to rectangular plot, S11 parameter new report. See, now you get the graph. Before you didn't get the graph, now you are getting the graph. Now let us plot the other radiation patterns also. Go to radiation, insert file setup, infinite sphere. Select the 5 degrees, it's starting from 0 to 360, and the theta starts from minus 182 degrees. Click OK. Now our thing is over. Now let us see the different antenna. Go to this, sorry. Right click on it, click compute antenna parameter. You see the different antenna parameters have been plotted for you. Now let us see if you want to see the radiation plot. So go to results, create file field report, go to 3D polar plot, select category as gain, quantity gain total, function as none, and click OK. Now you see this is the 3D polar plot you will be getting. Now it is having a maximum gain of 8.6. This is the maximum gain of this antenna. If you want, you can rename this as this. Go to rename and name this as S parameter. Suppose name this as your 3D polar plot. Rename this as your some 3D polar plot only. Okay. Next, if you may ask me, Yashwardhan, I want to see the. Now, friends, you may ask me, Yashwardhan, that's okay, but now I want to see how it is flowing on this, how it is polarizing on it. So to do that, or that also you can observe. To do this, just select, select the plane number 1 and plane number 2 also. Click on here. Go to plot fields, electric field, magnetic electric field. Leave everything as okay and done. Click done. Now you can observe this. Now you may ask me, Yashoda, I want to see its animation effect. So to do this, go to field overlays, electric field, magnetic field, magnetic of electric field. Go to here, click on animate. Let us say it is starting at 0, ending at some 150 degrees with a step size of, let us say, 10 degrees. click OK. See, now you can observe this is how it is parameting. If you want, you can even calculate its magnetic field also. To calculate the magnetic field, now you may say, Yashwardhan, I don't want to see the electric field, I want to see the magnetic field. Go to plane number 1, plane number 2, go to here, go to assign plot electric field, go to magnetic field, magnitude of H, click done. Okay, and then again click on this and just click on animate, click on same thing. You can run the same animation and you can see this thing also. This is not the case that if you want you need to assign for both. You can assign individually also. Now if you want you can assign individually also. Friends, now I hope friends, okay friends, I have also told you what will be the difference. I will show you the difference whether you applied this or not. So let us see that also in this video. So to do this, just go to unassign, select the monopole, right click on it, click assign excitation, assign your boundary, some perfect electric field, click OK. Now again go to analyze all and click on this. Now again click on analysis. See, now you get one error. Friends, now if you observe, the moment I applied this and again I click on analyze all, I got this error. It is saying now too many conductors have been in contact with the source. So it is advisable should not to add any radiation to this attractor. So just delete this electric field 3. Friends, now you see this after the completion it is saying these are the things, that is too many conductors are now conducting. So I have deleted the perfect electric field 3 and now if I click on analyze all again. Friends, now you can see that after I have deleted the perfect electric perfect T3 that I assigned to this monopole antenna. Now everything is there. All those errors have been disappeared and only now I am getting normal completion. Now again if I plot the results I will get the results back. I hope friends you like my explanation on how to design the CPW monopole antenna. If you like my explanation, please like this video, share it with your friends, and do subscribe my channel. If you have any ideas on what kind of video should I do next, please comment. Please keep your suggestion. Keep it in the comments down below. Or if you get any doubt, please feel free to comment that also down below. Thanks for watching, friends, and have a nice day.